So my project was on cartoon classification using TensorFlow. One issue today is that there's a lot of great image classifiers, but they just work for photographs. If you try to upload a cartoon image, you'll get something like this. It'll say it's line art, but it won't give you the full context, which isn't always that helpful. So the solve was collect our own data set and train a TensorFlow model that can classify cartoon images. I did this by taking the Chrome plugin, Gallerify, which will download images from search results. And I picked 10 different categories. And so here's a sample of what they look like below. I also wanted to establish a baseline. So this is not my solve. This was more just a sanity check. So I used the best models that won the ImageNet competitions, both Inception and MobileNet. And Inception did better with 67%, which is actually really impressive. That's a pretty great generalized model for a very small training set and pretty different from photographic data. So my goal was to hit that level of accuracy or better. In my final solution, these are some of the things that worked and that I kept. So I resized all my images down to 64 by 64 pixels. I converted them to grayscale and mirrored the images. Actually, I created duplicates of images in the training set, flipping them from left to right. I used concatenated rectified linear units for the activation function and the momentum optimizer with a 0.001 learning rate. I used one fully connected layer and no convolutional layers. And this is what that TensorBoard graph looks like for the architecture. And here's an example of the final images. You'll see that it predicts a lot of things as fish. I think this is because I had a lot of fish in my training set. So that's one solve that seems pretty straightforward to prevent overfitting to fish. Unfortunately, the highest accuracy I ever got was 32%. I tried a lot of different variables and that was there, so it was a bit disappointing not to get it as high as Inception. That being said, Inception is a very complicated model, so maybe my expectations weren't realistic. Another thing that worked was, so all the settings that I showed in the last slide, or 2 slides ago, and then also making sure I was saving each scalar separately when I had different hyperparameters, so I could see in the plotting when I got better performance. What didn't work? So surprisingly, adding convolutional layers decreased performance just slightly, but it also slowed down the model building process. And then flipping images upside down, I thought maybe if you go left to right, upside down would be helpful. It actually decreased performance. And then keeping images large caused overfitting of my training data. And here's just an example of the final. This is the more complicated model. I provided this as well if you want to take a look at it, but unfortunately it didn't work. Thanks so much for checking it out, and feel free to let me know if you have any questions.